Hi, I'm Libby Holmgren, Supervisor of the Math Resource Center at JCCC. Welcome to the TI-83 graphing video. At this time, it would be a good idea for you to pick up the note sheet that is available to you in the Math Resource Center. That way you won't have to take notes, but instead you can concentrate on actually using the calculator. We're going to start by pressing the Zoom key. It is located up at the top, right in the middle. You notice that you have quite a few different choices here, and we're going to go down to Z Standard. In order to access it, we could either push the number 6 on the calculator, or we could arrow down to it and press Enter. Notice the screen that you have has an X and a Y axis on the calculator screen. The X-axis seems to go from -10 to 10, and the Y-axis from -10 to 10. Let's check that out by actually pressing the window button that is located next to Zoom. You notice that the X-min is -10, the X-max is 10, the X-scale is 1, which means that there is a tick mark at every 1, the Y-min is -10, Y-max is 10, and Y-scale is 1, which again means that there is a tick mark at every 1. Let's start off by entering the function y equals x squared minus 6. In order to do that, I will press the y equals key, which is the upper left-hand key on the calculator. In order to get the x, we have a special key. X is the most used letter in mathematics, and it has its own special key on this calculator. It is located right next to alpha, and it looks like x, t, theta, n. But considering the mode that we were in, we are always going to get the x when we press this key. So press that key at this time, and you notice that x appears on the right side of the equal sign. I want to have x squared. The squared key is over on the left-hand side of this keyboard. Press it at this time. Notice that the x doesn't appear again, just the square. Now I want subtract 6, and make sure that you use the subtraction button, not the negation button. Finally, the 6 completes the entering of this particular function. Now notice that the y is alone on the left. In order to enter any kind of a function into this calculator, you will have to have the y alone on the left-hand side before you actually begin to enter the function into your calculator. So it may require a little paper and pencil work on your part before you are ready to put different functions into the calculator. Now, in order to graph this, all I have to do is to press the graph button, which is the upper right key. And you see that the function is graphed. I am going to move left and right and up and down by using the arrows. So just play around for a moment by using your arrow key, and you notice that you see a little cursor that looks like a plus moving around on the screen. At the same time, please notice that there are numbers at the bottom of the screen, one for x and one for y. These numbers will denote where the cursor is at that particular moment. Now, a lot of times in mathematics, we would like to actually trace on a curve. And rather than hoping that this little plus sign can be placed right on the curve, we can actually use the trace button on the calculator. That is located right next to graph, so press it at this time. Now, if you move with your right and left arrow keys at this time, you will notice that the cursor is actually moving on the curve, and that is what I wanted. At the same time, you notice that the numbers at the bottom of the screen are still reflecting the placement of the cursor on this graph, but also notice in the upper left-hand corner that we actually have the function written, y1 equals x squared minus 6. Let's go back to y equals for a moment. You notice that over there on the left-hand side of y1 that you've got a little slash mark. What that indicates is the way that this particular function will be graphed. Arrow over with your left arrow key until your cursor is way over there on top of that little slash mark. And press enter a few times to see what happens. You notice that you are getting some different things happening as you do it. And actually, these are going to be different ways that you can graph any particular function. Now, I'd like you to get to the point that the mark to the left of y1 looks just like mine. So go ahead now and use your enter key enough times so that you have a fat line blinking over there on the left. When it looks that way, we're going to press graph up here on the upper right, remember? And you notice that you get your parabola back again, but this time it is graphed with a thick mark rather than that thin line that we were used to before. Let's press y equals and see what else is available to us. If I press enter again, when I get over there on top of the line, I'm going to press enter. I'm going to enter on through until I see a little circle with a dash next to it. Okay, so I'll wait a moment until you're ready. You've got your little dash with a circle. Let's graph and see what happens then. You'll see that your parabola is being traced with a leading cursor of a little circle. Okay, let's go back to y equals. With your left arrow, move on over to that same position over there on the left of y1, and let's press enter till all you have is a little circle. Now you're going to have to watch carefully because this happens quickly, but when you press graph, then what we should see is an animation of this parabola. Okay, let's press graph, and we see this little circular cursor is tracing the parabola that I had entered. Press y equals when you're all done, and let's go back over there on the left and let's change that cursor by pressing enter back to the original. Well, we've got one more. We've got some dots. Let's see what happens when I leave it on the dotted line and press graph. And you see that actually your parabola is drawn with a dotted sort of symbol. Okay, y equals, and let's go over, placing the cursor way over there on the left, pressing enter again, and I see that I'm back to my original mark. I think I'll stay with this for a while. At this time, I'd like to enter another function, so put your cursor over on the right and down so that it shows that you're ready to enter a second function. We're going to enter the function 1/2 x plus 3. Now you'll notice that when I entered it on my calculator that I put 1/2 in parentheses. Be sure that you have entered it exactly the same way. If you don't put the 1/2 in parentheses, then you will get a different graph than I have. In other words, this calculator will do a lot of things really well, but if you enter a function the wrong way, then you'll get the wrong graph. So go ahead and put the 1/2 in parentheses, or if you want, you could put 0.5, which is of course the decimal equivalent of 1/2, and then you wouldn't have to worry about the fraction bar at all. Let's press graph when we're all set. You see that the parabola was graphed first and then the line. Let's press trace. You notice that in my upper left-hand corner of the screen it says y1 equals x squared minus 6. And if I move along with my left and right arrows, I see that my cursor is on the parabola. Now, at this time, if I use my up arrow, I see that the cursor hops to my other function. I am now on the line, and if I use my left and right arrows, the cursor is moving on the line, and at the same time I notice that in the upper left-hand portion of my screen, I have y2 equals 1/2 x plus 3. So the calculator is telling me which function I am tracing at this particular moment. Now I'm going to go ahead and choose a different zoom capability for a moment. So go into zoom by pressing this zoom key at the upper middle portion of your keyboard. I'm going to go to zoom decimal, which is number 4. Now it's kind of hard to see this graph at this time, but when I press trace, I want you to notice that when I move around that my numbers are a little bit nicer. There was nothing wrong with the numbers that I had before, but these numbers are a little bit easier to read, and you will find that when you are ready to have numbers that are rounded to the nearest tenth for the x value and the nearest tenth for the y, or the nearest hundredth for the y, that you will probably want to use zoom decimal. Now, if I would like to have zoom decimal, but I still want to see this picture and see more of both of these graphs, I could zoom out at this time. So let's press zoom again, and you notice that zoom out is the third choice. So go to number 3, press enter, and my calculator has zoomed out, but I'm still basically in the zoom decimal capability. So if I press trace and move along, I see that I can actually see both of these curves at this time, but I have nicer numbers on the bottom of the screen than if I hadn't used the zoom decimal. Now remember that a good way to start new problems is with zoom standard. So I'm going to go back now and go to zoom 6, because I'm going to enter a couple of other functions to go with the ones that we already have. Go over to y equals, arrow down to y3, and at this time I'm going to enter the function y equals 1 over x minus 2. Parentheses are very important here as well, because I want the x minus 2 to all be in the denominator of this fraction. If I forget my parentheses, then I will not be getting the same graph as I would to do the one that I really want here. Let's enter one more function before we get going, and that is going to be y equals the absolute value of x plus 1. Now, in order to access absolute value, I'm going to go to the math key over here on the left. I'm going to go over to num, so use your right arrow to go to num, and you see that ABS is right there at the top. So press enter and you have ABS, which stands for absolute value, and next we will type in x plus 1. Now the calculator has already given you the left parenthesis, and it will be important for you to put the right parenthesis where you want it so that you can show the calculator that you actually want the absolute value of the quantity x plus 1. Press graph now and let's see what happens. We have 4 different functions on there, and it's quite a mess. How would we ever know what was going on in this screen? So one thing that we like to do sometimes is to actually leave the functions entered into the calculator, but we might want to turn 1 or 2 of them off. So go over to y equals, and at this time we're going to leave only the third one on, and we're going to turn all the others off. So put your cursor on the equal sign. You notice that there's a little black box on the equal sign. Well, when I move over to the left where my cursor is actually blinking on the equal sign, I will now press enter. And when I move away from it, you notice that there isn't a little black box anymore on that equal sign, and that means I've turned it off. But it's still there waiting for me if I should like to use it later. I'm going to do the same thing on the second function by pressing enter when I'm on the equal sign. Move on down to the fourth one and do the same thing. Now I'm going to arrow away from it so you can see those equal signs. The only function that has a little black box on the equal sign is the third function, and that is the one that we're going to look at for a moment. So when I press graph now, I should see only the third function. Now you may not yet be familiar with what this graph should look like, but you will be soon. Let's press trace and see what happens. Something strange seems to be occurring when x equals 2. So watch the bottom of your screen as you use your right arrow key, and notice that as these x values get closer to 2, my y values are getting much smaller. I'm at 1.9 for the x value right now, and my y value is approximately negative 12. Now if I keep going with my right arrow, I jump over the number 2, because these numbers don't always come out to be really nice, and I see that the x value is actually past 2. It's about 2.13. And my y value is positive now, and if I keep going to the right with my arrow key, I see how these numbers change. Now there does seem to be a line going up and down in the middle of the screen. This is actually not part of the graph, and when you get to this portion of your mathematics, you'll know that this is not an actual part of the graph, but instead it's called an asymptote. And what's happening right here is that this calculator is connecting the left and the right pieces of this graph together, but that the line that we see is not actually part of the graph. Now, there is a way for us to sometimes get to a point where we don't actually have to see that line, and one thing that you can do is to go back to zoom decimal, which we did a few moments ago. So press your zoom key, go down to number 4, press enter. We'll see this function regraphed, and press trace. Now watch your x values at the bottom of the screen, and you notice that I'm getting closer to the value of 2. That's my my point here is that I want to see how close I can get to the value of 2. And even if the cursor goes out of sight on the lower portion of the screen, it's actually still moving on the curve, and my x values are getting closer to 2. Now I'm there. Now when my x value is 2, exactly 2, notice about something special about that y value? There's nothing there. Okay, the function is undefined when x is 2. Okay, let's go back to y equals. And now we're going to turn on only the second function and the fourth function. So leave number 1 off, go down to number 2, move over to the left, press enter, and that turns on your second function. Go down to number 3, press enter to turn that one off. And on the fourth function, press enter to turn it on. Now just to check to be sure that we've got what we want, move your cursor off to the side a little bit and notice that there is a little black box on the second function on the equal sign and a little black box on the fourth function on the equal sign, and these are the 2 functions that I wanted to have on, so I'm in good shape. Let's go back to Zoom Standard, a good place to start any problem. And we will see the equation of a line and the equation of an absolute value function. We're going to talk now about zooming in. We've got 3 or 4 different ways to zoom in on different places on our graph, and I'm going to see if I can find where these 2 graphs intersect each other. Now they actually intersect in 2 places, but I'm going to pay attention to the place on the left-hand side of the graph where they intersect. So let's trace and put the cursor over in approximately that spot where I can see that those 2 graphs intersect each other. And when you're there, we're going to zoom in and see how close we can get. So press zoom, go to number 2, press enter again. Now the calculator is zooming in to see how close it can get to that little spot. Now let's press trace, and I can arrow over, and I'm much closer than I was before, so if I wanted a good guess as to where these 2 curves intersect each other, I could say the ordered pair is approximately -2.7, 1.7. Okay? That's one way to zoom in and see where these 2 graphs are crossing each other. Now another way I can do this is with box. And in order to experience that, let's go back to Zoom Standard with Zoom 6. And we're going to look at the same place. Use your trace key, arrow over and get really close. Put the cursor right where they seem to be intersecting. Now we're going to go to zoom again, and Z box is number 1. So choose that one. And at this time, take your left arrow, move it to the left and above. Use your up arrow to go above so that your cursor is to the left and above the place where our 2 graphs are intersecting. Now when you're happy that you're at a point that is to the left and above, hit enter. You've got a little box now on your screen, little tiny box marking the upper left-hand corner of what our big box is going to be. Move down with your arrow key, and you see that a box is being drawn. When you're happy with that, move with your right arrow until you have formed a box. Remember, we're using Z box or zoom box. Now when you have a little box drawn around, well, maybe I'm a little too wide. I'm actually only interested in where those 2 places, those 2 graphs intersect. Maybe I got a little too big. So I've adjusted that a little bit now, and when I'm happy with it, I'll hit enter. And my calculator has zoomed in on the box that I denoted for it. Press trace, move over to the place where it looks like they're intersecting, and again, I've got a pretty good guess, and it's probably even closer than the last one that I got. But if I were to round it to the nearest 10th, I would have -2.7, and let's see, the y value is 1.7. So if I'm rounding off to the nearest 10th, I have approximately the same thing that I did last time. Okay, another way to find out where 2 graphs are intersecting is to use the calc aspect of the calculator. But let's go to Zoom Standard to start this part of our video. Use your trace, get over there really close to the place that the 2 graphs intersect each other, And calc is located right up above trace. So let's use the second key, calc. And we have a number of different choices here. I'm going to go down to intersect because that's what I want to know, is where these two graphs intersect each other. So when I'm there, I choose it, and I have a question on the bottom of the screen. It says first curve question mark. Okay, well, I like where my cursor is on the line, so I'm going to press enter. And when I do that, it now says second curve question mark. And notice that up on the top of the screen, up in the upper left, I've got y4 equals absolute value of x plus 1. The calculator has hopped to my second function, and yes, I'm happy about where the cursor is on the second function as well, so I will simply press enter. And now the calculator is basically asking me if I want it to take a guess, and I do, so I will press enter. Now the calculator has given me the intersection of these two graphs, and it's much closer than it was before. As a matter of fact, you can see that negative 2.666667 is probably negative 2 2/3. And when it says that y equals 1 point, many sixes and then a 7, it probably is 1 2/3. So we get a really good estimate for this intersection point by using intersect in calc. Okay, let's talk about something else. Let's talk about finding the zeros of a function. In other words, finding out where a function crosses the x-axis. So at this time, we're going to go back to y equals, and we're going to turn on only the first function. So use your left arrow to go to the equal sign, turn it on, and move down and turn off the other two that were on a moment ago. And if I move away from that, I see that the only function that has a little black box on the equal sign is the first one, and that's the one that I want this time. Okay, let's go to zoom standard, get a good picture of this parabola that was our first function. And at this time, we're going to use the calc menu again. So go second, calc. You see that the second choice says 0. So we're going to find the x-intercepts by going to number 2. And I have a question on the screen again. This time it's asking me about the left bound. Well, you see that this particular function has two different places that it crosses the x-axis. And we're going to have to tell the calculator where we want to be paying attention. So let's move the cursor. I've decided that I want to find the 0 that's over here on the left. So I'm going to move my cursor now to the left of that particular spot. Now I know it's above, but it's left, and that's the question that's being asked of me on the bottom of the screen, is left bound question mark. Now when I'm happy that the cursor is to the left of my spot, I'm going to hit enter. And now you notice that there's a little arrow that has occurred on the screen that shows where my left bound is. And I have another question on the bottom now that says right bound question mark, so I'm going to move the cursor with my right arrow over there so that it is on the right-hand side of the spot that I'm interested in. And when I'm happy with it, I'm going to press enter. And at this time, there's another little arrow that is occurring sort of near the top of the screen. And these two arrows are denoting the space that I'm interested in. The question on the bottom of the screen now is guess. Yes, I want the calculator to take a guess. If I want to, I can get even closer with my cursor, which I just did. And when I press enter, I will get a good guess for the 0. And you notice that it says y equals 0 for the y coordinate of this ordered pair. The x value seems to be negative 2.44949. Now there's another aspect of finding the 0 that we're going to look at that is unique to this calculator. Let's go to zoom standard to kind of clear everything out here. Go to second calc again. Notice that calc is located up above trace. Go to 0 like we did last time. And this time when it asks for left bound, instead of arrowing over to it, I'm going to simply put in a number by typing it in. Now if I look at my graph, I see that that left-hand 0 seems to be occurring between -2 and -3. So I'm going to type in, now that it asks me for left bound, I'm going to type in -3 and then press enter. And the arrow has occurred in the upper left-hand portion of my screen. Now the calculator is asking me for the right bound. So instead of cursoring to it, I'm going to type in -2. Press enter. And the calculator is actually asking me if I want it to take a guess. I think I'll put in negative 2.5 as my guess so that I can get close, and then when I press enter, the calculator gives me the value of the 0, and I got the same thing that I did last time. But this was a little bit nicer because I could actually type the number in instead of arrowing over to it. So there's a couple of different ways that you can use that 0 capability of the calc menu. Okay, let's go over to y equals now, and we're going to clear out all of the functions that we've been using by simply pressing the clear key over here underneath the arrows. So clear that, move down, clear, move down, and so on. Then move your cursor up here to the top, and we're going to enter a new function. This time we're going to make negative 4x squared plus 14x plus 400 be our first function. When you get that function entered in, let's go zoom standard and see what happens. Well, it doesn't look like much. Let's think about what we expected to have happen at this particular time. Since it has an x squared in the function, we would expect this to be a parabola. Since there's a negative in front, we would expect this parabola to open down, and that is not what we see on the screen. And if we take a look at that 400, that's a good clue as to why we can't see what's going on. In order to find a y-intercept on a function, remember that we might place a 0 in for each of the x values. If I do that, I find out that this particular function has a y-intercept of 400. Well, since our particular graph only goes up to a maximum of 10 on the y-axis, it's not surprising that I can't see that 400 up there. So we're going to do something else on this calculator to make sure that we can actually see the graph. Go to zoom, and I want z-fit. Now I can't see that, but let's arrow down past the 7 there. And I see there down at the bottom, at the number 0, I see zoom fit. Press enter. You see there, that little worm that we sometimes call it up there on the upper right-hand portion of the screen is moving, and the curve did regraph, and now I can see it. Let's see what happened to the window by pressing the window button at this time. You notice that the negative 10 and 1 have all stayed the same on the x's, but that the y values have really changed. Let's go back to the graph. Now, it was nice to be able to get to the graph, but perhaps we don't like this very well. Zoom fit allowed us to get the graph, but let's fix it up a little bit better. I think I'd like to see the right-hand portion of the screen where the parabola comes down and crosses the x-axis. So I'm going to decide to make the x max somewhat larger. Let's go back to window, and I think I'll maybe change this y max, the x max, that's what I want to change. I want to change the x max to 15 and see what happens when I graph. Okay, now I can see where it crosses the x-axis on the right-hand side, and I like that. And also, my curve is really close to the top, and when my function ends up being written up there in a moment, I'm not going to be able to see the top of this graph. So I'm going to go into Window and change my Y max to a larger number. So press Window, and for my Y max, I think I'll just change it to 500. Press Graph. So I'm liking this better and better. The only thing now that I think I'd like to change is the fact that there's such a thick line in the middle there, and that's because of the scale on the y-axis. So let's go to Window and do one more change. Notice that the y scale is still 1, and what our calculator is trying to do is put a mark, a tick mark, at every 1, and that's going to be pretty hard when the y-axis is going from negative 140 to 500. So why don't we change the y scale to something larger, like maybe 50. Press Graph, and you notice that the tick marks are showing up now, but we do have to keep in mind that the tick marks on the y-axis are each worth 50, and the tick marks on the x-axis are each worth 1. Okay, now that we've got a nice picture of this parabola, we're going to try to find the maximum of it, and the first thing we're going to do is just press Trace and cursor over to it. So if I press Trace and use my left and right arrow keys, I'll have to watch, I don't know, it looks pretty flat up there on the top. It's real hard to tell. But if I watch my y values and try to get the largest value possible on the y's, then when I think I'm there, that would be my guess for where this maximum occurs. I guess since the largest value I can get on y occurs right here, that I'd probably say that the maximum will be occurring when x is approximately 1.7. But there is a better way to try to find the maximum, and that's to use the calc menu again. So let's go second, calc, and we're going to go to maximum, which is number 4. I get a question again. What do I want to be the left bound? Remember, you have a couple choices here. You can either arrow over to the left of it, or you can put in a number. I think I'll type in the number 0. Press enter. And then it's asking me for a right bound, so I think I'll just type in the number 3 because I'm pretty sure that our value falls between 0 and 3. Press enter. And now it's asking me for a guess. I actually don't have to enter anything, but I think I'll put in 1.5, which happens to be right between 0 and 3. Now when I press enter, the calculator will find the maximum is occurring when x is 1.7499976 and the y value is actually 412.25. And we've done several things on the calc menu, but you'll notice that there are other aspects of the calc menu that you'll probably want to use yourself in the future now that you know that they're there. Okay, let's go back to y equals and clear that function out. Let's go to zoom standard just so we know that we're back to that normal screen again, even though there's not a graph at the particular time. Go to y equals, and I'm going to have you enter the 3 functions that you see on the screen at this time. We're going to have the x plus 3 for our first function. Arrow down, then I want you to put that the y2 function is 4, and that the y3 function is negative 1/3 x plus 4. Again, make sure that you have parentheses around the 1/3. Now, it won't make any difference if you put the negative to the left of the parentheses or if the negative is included in the parentheses, but the 1/3 simply has to be in parentheses or you will get a completely different graph. Press graph to see what happens. And as expected, we got all 3 parts of the functions on that screen there. We've got all 3 of them. We've got 3 different lines showing up. Now we are going to graph the piecewise function that you see on your screen at this time, and you see that that piecewise function is made up from parts of the 3 functions that we just graphed. Now how is it that we will get parts of all of these functions and not all of them? Well, let's go back to y equals, and we're going to put parentheses around the x plus 3 to begin with. Remember, in order to do insert, I do second, and then INS is located over here above DEL. Press the left parenthesis, move on over, pass the 3, put the right parenthesis, and I have done the parentheses around my function. Now I'm going to place in the restriction. Start with a left parenthesis, then I need x, and next I need the less than or equal to symbol. Now this is located above math under the test menu. So go second, test. I need less than or equal to, which is number 6. It hops right back into the home screen. Now I type in -1 and then close the parentheses. So my first part of my piecewise function has the restriction that it needs. Let's arrow down and put the restriction on the 4. So let's insert a left parenthesis, move on over, close that parenthesis, and now I'm ready for the restriction here. So a left parenthesis, then I need -1. I need less than, so I go into test, second, and then hit that math key. Less than is the 5th choice, and I'll press my X. At this time, I am not going to be able to continue and do the less than symbol again. Instead, I'm going to go to the word and, which is in the test menu again. So go second, test, and go over to logic by using your right arrow. You see the word and has occurred on the screen, and now I'm going to say that x is less than 2. When your screen looks like mine, you're ready to go on to the third function. Yes, we do need to put parentheses around this function, and even though we have a parenthesis at the beginning, I still have to insert another one. Move on over, put this entire function in parentheses, open another set of parentheses, and now we're going to say that x is greater than or equal to 2. Greater than or equal will be found in the test menu. Number 4, put 2 in there and close the parenthesis. When you do have your functions entered as mine, then we're going to go and see what happens when we graph this function. It's actually one function at this time, not 3. Okay, we see the pieces, but at this time these pieces are connected to each other and we don't want that to happen. So let's go into mode, which is located right next to the second key, and we're going to go down to where it says connected, move over to dot, and press enter. Now when I graph this function, you'll see all 3 pieces, but they won't be connected to each other with up and down straight lines like we had before. And this is actually what your piecewise function looks like. Okay, let's go into mode, change it back to connected for a minute, go to y equals, and get rid of all 3 of these functions. We're going to do a different function next. So press clear on each of these. Let's do the greatest integer function. Now you might never have seen this before, but it is something that you will see sometime in the future. In order to do that, I need to go into my math menu, go over to num, and choose number 5, which is int. That stands for the greatest integer function. You notice that you have a left parenthesis, so all you have to do is put in the x now and close the parenthesis. Let's see what happens when I graph this function. Looks like a bunch of steps. And this is what it should look like, but this function shouldn't be connected either. So let's go back to mode, go down and take it off connected and see what happens when I put it on dot, and then graph it again. And this is the way the greatest integer function should look. Okay, let's move on to another aspect of this calculator. Go to y equals, clear out that function, and let's enter the function x squared minus 1. Excuse me, x squared minus 2 is the one that I want to do. Go to Zoom Standard. I have my parabola, and if you had any doubts about it, you could press trace. You could see the parabola is listed in the upper left-hand corner, and I see my cursor there ready to be moved if I should like to do that. Let's go into mode now. Now we've been on mode before because we chose connected versus dot. Let's put connected back on, but we're also going to go down on that last line where it says full, and we're going to go all the way over to the right where it says G-T, and we're going to press enter. And that means that we're going to get a graph and a table on the same screen. So when I press enter and then the graph key in my upper right-hand corner, I will get both a parabola on the left and a table over there on the right-hand side. Let's press trace and see what happens when I move around on my curve. You notice that the ordered pair occurs on the bottom of the graph, but also that the cursor is moving on my table according to where I am on the graph. This is a pretty neat aspect of this particular calculator. Now I'm going to go to Zoom Decimal because my numbers over there on my table are fairly complicated looking, so I'm going to go to number 4, press trace, and then if I move, I see nicer numbers. It's not a necessity, but it's kind of nice to see some nicer numbers. Now if I go beyond the the table that's originally set up, but I keep going with my cursor, notice that the table will just continue on with me no matter where I am. Okay, let's go to mode and take this particular aspect off by going back to full. But remember that that GT is there for you to use. Go to y equals, clear out this function, and we're going to enter the function the square root of x. Now remember that the square root symbol is located up above x squared, and since it's in yellow, I'll have to do second. Press X, and then close that parenthesis, because whenever the calculator gives you a left parenthesis, you must make sure that you put the right parenthesis in there in the place that you want it. Let's see what this graph looks like. Now I'm still in zoom decimal, which is just fine. For those of you that have studied the square root function, you'll know that this is exactly what it looks like. Now, something that comes up a lot in college algebra and in pre-calc is shifting and reflecting of graphs, translation of graphs. And we're going to consider a couple of other functions and how they are related to this particular function. So if we would like to do the function y equals the square root of x plus 1, where the x plus 1 is all underneath the square root symbol, then remember that that function should be shifted to the left. Let's see what happens when I enter it into y equals. Move down to the second position, put your square root symbol in, and now do the x plus 1, then close the parenthesis. That means that you're telling the square root symbol that you want the x plus 1, all the quantity, to be underneath that square root symbol. Press graph at this time and you'll see the original graph as well as the new one. So there's the original and here's the new, and it has indeed shifted to the left. Let's go over to y equals and type in a third function, the square root of x, close parentheses to show that that's all I'm taking the square root of, then type in plus 1, so that plus 1 is kind of off to the side. Now, you will either learn or you have learned that this means that the particular function that we started with is going to shift up 1. Let's see what happens when I press graph. I have my first two functions, and now the third one has shown up, and it is the original function shifted up 1. So you see how they are all related. Now, what do you suppose would happen if I forgot all about where I was supposed to put the parentheses? Let's go over to y equals, and I'm going to clear out the last two functions, leaving only the original. And in that second position, I'm going to put the square root symbol, put the x in, put the plus 1, but I'm going to forget to put my parentheses. And that means that the calculator really doesn't know for sure whether you want to enclose the x plus 1 underneath the radical sign or whether you just want the x there. So I'm going to press graph and see what happens. I see the original function, and I see that the function has moved to the left one place. But I guess the real point here is that when you are entering functions, be sure that you put the parentheses in where you want them, because the calculator may have to take a guess at what you want otherwise. And that isn't a very practical thing to do if you want to get a graph of something accurately for your homework. Okay, let's clear out these two functions. And we're going to enter the function x to the power of, remember this caret over here up above the division symbol, the power of 2/3. Now I'm going to have to put that 2/3 in parentheses in order to get the graph that I want. Press graph, and you'll be able to see this entire function. The TI graphing calculators that came before the TI-83 had trouble graphing this function, so this is an improvement on the TI-83 in that the x to the 2/3 can be fully seen. We don't just see part of the graph. Well, let's try a trig function next. Let's go to y equals and press clear. Let's graph the sine of x, and you notice that sine is over here up above the comma. Put the x in, close the parentheses, and press graph. Now, for those of you that have learned about sine functions, you'll notice that this looks like the sine function, but remember that you're still in the zoom decimal screen, and this isn't really the best screen to look at a sine function. We need to go into zoom, z trig, which is number 7. It's made especially for trig functions. And this is more like what we would expect the sine function to look like. We can actually see more of it. If we go to window, we see what happened is that the x min is negative 6.15. The x max is 6.15. For those of you that have studied trig, you'll realize that the x min is approximately negative 2 pi, and the x max is approximately 2 pi. The calculator has done this on purpose because we chose zoom trig. So I would suggest that whenever you are graphing with trig functions that you actually start off with zoom trig, and then if you would like to make some adjustments after that, that would be fine, but it gives you a good starting place. Okay, the next thing we're going to do is to deal with a linear regression equation. Let's go in and clear out our y equals so that we don't have a function there. You see 3 ordered pairs on your screen. We're going to graph those ordered pairs, and we are then going to find an equation that closely fits those particular dots, those particular points. That's what we're going to do. You will learn more about this in statistics if you take it, but a number of people cover it in college algebra as well. So let's go ahead and see how it is that we would graph some points on our screen as well as the line that fits them. In order to enter the ordered pairs, I have to go to the stat key, which is located underneath delete. I want to go over to edit. Actually, that's the first choice, so press enter. And I am going to make sure that my cursor is under L1. That stands for list 1. I'm going to order all of the x, I'm going to put all of the x values in here. So I've got a 1, a 3, and a negative 1. Then I'll go back up, move over to the right, and in my L2, or my second list, I'm going to put the corresponding y values with each appropriate x value. And notice that it doesn't make any difference whether I use the down arrow or whether I use enter. I'm able to get all 3 of these ordered pairs entered in. Okay, now that they are there, I'm going to plot the ordered pairs by going to stat plot. Stat plot is located up above y equals, so I'm going to press second and then that y equals key, and I'm going to choose number 1 by pressing enter. Right now off is highlighted, so I'm going to press enter to turn it on. Now I can go down to the type. I do want all of those dots. You see 6 different choices, but I do want the dots, so go ahead and move on down. My X list is in L1, that's what I want, and my Y list is in L2, so I don't have to do anything different. And I do like the mark of the little square, so everything else is just fine the way it is. If your calculator happens to look any different, then go ahead and change the pieces right now so that your screen looks like mine. Now, in order to get our screen so that it's appropriate for these particular dots, I'm going to go to Zoom and use Zoom Stat. I can't see that, so I'll arrow down, and I see that Zoom Stat is my number 9 choice. Press Enter, and I see the 3 points on my screen. Go over to Window, and you'll notice that the window has definitely changed from before, and it has changed so that it can include all 3 of the ordered pairs that I have put in. It automatically did it because I was in stat plot, because I'd already turned on a stat plot. Then the Zoom Stat will work. Now let's go ahead and find the line that closely fits these ordered pairs. Go to Stat, go to the right to Calc. Oh, I went too far. There I need to be on Calc, and I'm going to choose the number 4, which is lin reg ax plus b. After that, I'm going to state where my ordered pairs are located. And in order to do that, I want you to notice that down here, up above the number 1, you see L1 written in yellow. So do second, and then press that 1 key, and L1 occurs on the screen. Then I want to put a comma. Then I want to put L2, because that's where the y values exist. So do second. The L2, there it is. I put a comma again, and I'm going to put one more thing in here. I want to have y1 showing up on my screen there, because that is where I want my linear regression equation to be. I don't want to have to type it in. I want the calculator to figure out the linear regression equation, and I want it to automatically insert it into the y1 position. So the next thing I'm going to do is to get y1 right there. So go to vars, go over to yvars, choose function, and choose the y1, and you see that the y1 hops into the home screen. Now that I've got these three things following lin reg ax plus b, I'm ready to press enter, and the calculator has figured out for me a linear regression equation using those 3 points that were located in list 1 and list 2. So I have approximately y equals 1.5x plus 1.8 if I insert the a value and the b value in the appropriate places in y equals ax plus b. Let's go over to y equals and check, and we see that actually the calculator has inserted that particular equation into y1. Now let's press graph, and we'll see that I not only see the ordered pairs, but I also have the line that we have just put into y equals. It's now graphed, and though it doesn't touch any of the 3 points, this is the closest line that we're going to get to matching those particular points. Well, this completes the video for graphing, but I want to caution you that before you quit, you should go back to stat plot and turn it off so that you don't have something else that gets mixed up in the future because of that. So let's do that together by going to second stat plot, go to number 1, and go to off over there on the right and press enter. Now there is another way that you could have done this. You could have gone to stat plot, and you notice that the 4th choice says plots off. If I choose number 4 and hit enter and then enter again, it says plots off, done. So I've actually turned this off twice. You don't need to turn it off both ways. Either one will work, but it's a good idea to do it so that something else isn't affected by this particular graph in the future. Well, go ahead and use your calculator. I hope you enjoy all the graphing aspects of it.